Hello CS112, so I'll be going over a quick solution to Lab 6, which has to do with multi-dimensional lists. So to jump right into it, you were to create a function called trace, where you will be given a matrix parameter, which is a 2D list, meaning a list where every element in that list is another list. You are to calculate the trace of it. In linear algebra, the trace of a square matrix is defined to be the sum of the elements in the main diagonal. So if we look at the example they provided here, it would start at the top left corner of a square matrix and then calculate the sum of the preceding diagonal. So in this case, it would be 5 plus -1 plus 7, which equals 11, as you can see here. And what we're returning is this 11. There was also an error check, so we had to essentially validify that we had a square matrix, as you can see here. We were not given a square matrix, so we were to instead return the string trace is only defined for square matrices. So I'm just going to jump right into it. Something that I will do is when I'm typically coding, I usually always code first and assume I'm going to get proper input. So I'm going to worry about doing this after I pass these other 3 test cases. So I'm just going to first assume I have good input. So if proper matrix, I'm going to put that little comment here. Well, obviously I'm going to be returning the sum of it, so what's it called? The trace. I'm going to set that equal to 0. And I mean, just thinking about it logically, we're going to have to somehow index at a different location. So essentially sublist at sublist 0, sublist 1, sublist 2, so on and so forth. So we're going to have to somehow change up that location. So I'm just going to call it slants because we are searching along the slants and we're going to be starting at the 0th elements of the first. So I'm going to set it equal to 0. Then I'm going to iterate through the matrix. So for I in range length matrix. So again, if I was to print out I right here, it would print out the number of the elements, or sorry, the index. It would print out the indexes here. So if I was to call this just, plain out for I in range length matrix, for this as my matrix, and I was to print out I, it would just print out 0 and 1 because it would iterate here at 0 and at 1. If I actually wanted to print out the specific elements themselves rather than just the index, I would type in matrix add I. So now if I was to print this out, it would print out the list 2, 4 and the list 4, 6. But that's not what we're doing here. I just wanted to make that clear. Now I'm going to want to actually iterate through the sublist so I can grab the sum of the slants. So I can say for j in range length of matrix I, because as I just demonstrated, matrix I is going to now be each of these elements, which are going to be sublists. I'm going to say if j is equal to the current slant. I'm going to add that to my answer, which is actually called trace, plus equals matrix ij. And before I get to my next sublist with this for loop here, I'm going to want to update my slant. So the next slant is at this location and this location rather than just 5, 4, and -3. So I'll do that right here because I want to do it, as I said, before this next loop gets to the next sublist. Something to point out here is that you guys should get comfortable with understanding what this means. So matrix ij, that is going to index at matrix I. So again, I'm just gonna pull this list right here so you guys can see it a little better as the example. So here it's going to simplify it like this. So let's say we're on the first iteration, I is 0 and j is 0. So it's first going to bring out matrix 0. So it's going to simplify it to just matrix 0. So it's going to grab the 0th element of the matrix, which is the list 2, 4, and then at index j. So that's 0 and then 0. So it's going to grab 2. And it's going to plus equal that with trace. If I just said plus equals j, that would be adding the index, but not the actual value at the element. So that's why I'm doing plus equals ij there. Now I'm just going to return my trace. And let's see if I passed these 3 tests here, because I want to check that. I want to check that first. So if I type in py cat.py, so I'm just checking 8, 17, and 23. Okay, good. So I was able to get the correct output for the 3 correct ones. But now that I know my code works for proper input, I'm going to put in the debugging code to make sure I'm getting a good matrix. So you need to check if the matrix is square first. And we were told that we can use the length function, so I will be implementing that. So first you want to check if the length of the matrix is not equal to the length of matrix 0. Now I am making the assumption that we will be given at least a matrix with 1 sublist. Then I'm just going to print out, I'm just going to return this string right here. Essentially what I'm checking here with this length is I'm checking if the length of the matrix, so length of matrix is going to check how many elements are in this 2-dimensional list. So if you were to call length on this guy right here, it would count 1, 2, 3, and 4, and it would compare it to the length of the very first element, so 1, 2, 3, and 4. So that would be a square matrix, whereas if we check this one, the length of matrix, so 1, 2, and 3, does not equal matrix 0, the length of matrix 0, which is 1, 2, 3, and 4. So that's when you would return the little error message right there. And as you can see, now I'm still getting the correct output there. If you guys had any questions, do let us know. I really suggest you, even after watching this solution video, you try doing this on your own. You will be tested on, and your projects will have a lot of these nested loops going through multi-dimensional lists. So definitely get comfortable with like the syntax of what I'm doing here, of why this is matrix I, not just matrix, or not just I, why I'm doing matrix ij, all that stuff. It's all extremely important.